This is the second video in our experiment analysis series. We're going to pick up where we were in the first video, where we've identified people in the experiment with a match. We've checked that they're in the correct experiment, Top Movies XP. We've pulled forward their variant onto the sequence, filtered out people not in the experiment, and replaced anything that happened before the start of the experiment with null, so we've removed it. I'm going to comment out the first analysis and give me space to start my second analysis. Now I want to think about the average time it takes for someone to get to watch start. So the last experiment, or the last analysis, we were looking at the volume of watch starts. Now we're looking at how quickly they get there. So first I want to do this within sessions. So I'm going to use Copilot to sessionize my data. It looks like it chose 30 minutes. I'm going to change that to an hour because that's what we've been using. I talk more about this in the duration and sessionization video if you want to see the details of how to sessionize. And then we're going to match on watch start. So now that we're inside a session, this is going to find the first watch start within a session. And to calculate the duration, I'm going to add something to the sequence called dur, and that's just going to be the duration from seq0 to watch start. So duration is a built-in function to calculate the time between two things. seq0 refers to the first item in the sequence. So that's whatever the first thing the user did was, and then watch start finds that first watch start. It's basically using this tag that we've generated when we did the match. And you can see for every session, we have the user's variant, and then we have the time in that session it took to get to the first watch start. Now, some sessions aren't going to include a watch start, so you see null here. We're going to want to think about how to handle that eventually, but let's keep going for now. So now I want to analyze this on a user basis. So I'm going to recollapse all those sessions back into users with a combine. And then while I'm combining the users, I'm going to average their duration value. So I'm going to set that to the average of duration. So now if a user had 100 sessions, I'm averaging the duration of each of those, the time it took them to get to watch start in each session, into a single value. If they had just one session, it's going to be that value. And those null values are getting sort of collapsed in here as well. If a user never had a watch start, of course, this value would be null as well. Okay, so now we have each user, we have the average time it takes for them to get to watch start in a session, and we have their variant, and from before, we're limited to data in the experiment. So let's head over to plot. I'm going to do a histogram on that average duration. And so we've got count star for average duration, and then I'm going to group by our variant. So I'll see the two different variants as histograms. I know there's a lot of bins here, but I kind of like this view to see how the treatment shifts behavior. So treatment's in orange, and you can see that orange distribution is shifted over from the blue distribution. And so that tells us that the treatment did, in fact, pull forward the watch start event. It made it, so that it took less time for a user to get to watch start. Now, we don't know the impact of those null values right now. So, they're kind of hidden inside the average, or if someone only had null values, they're just not present here. So one thing I can do is normalize my count star by taking the percentage of all, including null values. This will really only take into account those sessions or those users that had only null sessions, because otherwise they're going to have a value for average duration that sort of hides those null values. So one thing I can do is basically replace the null values with something that's semi-meaningful. So out here we're at about 5 minutes, which is kind of well outside the main distribution. So if I took every case where a duration was null and replaced it with 5 minutes, we'll see what happens. So I use an operator called coalesce, which basically says replace any null values, and I'm replacing them with a 5-minute duration. So I'll hit run query. Now on each session, it's being replaced with 5 minutes, and then it's averaging, of course, that in when it combines those sessions. So our distributions look a little different. The control group actually looks shifted out even further from the treatment group. And then out here I have these two spikes at 5 minutes. So these are all the sessions, or all the users that had only null sessions. And I can see that the blue spike is larger than the orange spike down here. It's probably hard to see. But that also gives me some confidence that for whatever reason the treatment didn't just create a lot of null values and only keep the good values. So that would be a way that the experiment would sort of like cheat around a really rudimentary analysis. But I like this. This feels good. We're sort of penalizing the cases where a user doesn't get to watch start. So now let's do our analysis of the two variants. So I'll change my x-axis to variant. I'm going to change my dimension to average duration. I'm going to get rid of the group by here. And then I'm going to aggregate that average duration as a mean with error bars. So I'm basically just averaging the average duration within the treatment and the control group. Okay, so we have on the control side an average of 142.86 seconds. So it's 2 minutes to get to that first watch start. And on the treatment side, 101 seconds. So just a minute and a half to get to that first watch start. So the treatment definitely had a positive impact. We see small error bars because we're dealing with pretty large numbers here. Now remember, we've sampled the data set down to 12% to keep this fast. So I'll hit query more here, and that'll run the same analysis over the entire data set and get us our final values that we're interested in for this final comparison. And it takes about 10 seconds, so I don't want to do that every time. But I need to do it to get these kind of like values for my presentation, or to make sure I feel confident in the final result. It looks like it moved to microseconds here, but we have 142.5 on the control side and 101.8 on the treatment side. So after 18 seconds, we were able to complete this across our whole data set, and we see that the effect remains, that treatment has a significant advantage over control for this experiment. Okay, so we picked up where we left off in the first video, where we had identified the users in the experiment and the right data. In this video, we sessionized the data. We matched the first watch start in each session, calculated the time it took to get there. We ended up using a coalesce to deal with the null values, and then we averaged that across each user. And so we had per user values that we could analyze in our plot. First, we looked at the histogram to see the kind of like shift in the distribution of watch starts. And then we went into this basic summary view to see the overall effect on treatment versus control. Stay tuned. The third video is going to get even more interesting, and we're going to have a fourth video as well. So hope to see you there.